Good morning. This is a good turnout. Thanks for getting up. I've never spoken on a 9 a.m. slot before, so I didn't know what to expect, but this is excellent. So here's what we're going to cover today. Time permitting, given the 1 hour speaking, 30-minute question format, we might be able to get 2 talks into one here, I'm hoping. So the sort of part 1 will be Security Team 2.0, which is the content as described in the program. And what we're doing here is we're trying a new talk where we've sort of looked at some of the things we've done very differently to a traditional security team when we set up the Chrome security team. And we think some of the things we've done differently have worked out quite well, so we'd like to tell you about them. And of course, the hope there is that by freely sharing the things that we've done and our methodology, you might want to copy some of the things we've done when you find yourself setting up your own security teams in the future. The second thing is whenever we talk about what we've done, we find that one of the things people are most excited about and have the most questions about is our various reward programs. That's where we give monetary rewards to researchers who report things to us that we think are significant. So time permitting, we'll dive into the history there and some of the statistics statistics relating to the sort of amount we've paid, what we've paid for, and so on. And I also hope to leave lots of time for questions. So some brief introductions. Who am I? I'm Chris Evans. Informal, excuse me, an informal title of troublemaker, as Ellie said. I forgot my business cards, but if I had remembered to bring them with me, it says troublemaker. Some things I've done tailored to what's important for the things we're going to be talking about, just to give you an idea of where I'm coming from. So in 2009, I founded the formal Chrome security team. And one of the first things we did, and one of the best things we did in retrospect, was we launched a reward program to try and get more community involvement. That went so well for Chrome that Google-wide, in the same year, we launched a web reward program. That was kind of a big deal, we thought at the time, because inviting researchers to sort of download your client-side product and research it is very different from inviting researchers to research your live services. It's not like you can download Gmail onto your local machine and research it there. So we'll look at how that went. Following on, later we launched a competition format called Ponium with larger prizes, but with more difficult challenges. We'll go into that a little bit. I've done some open source work in the past, and when I'm not too busy, I do enjoy, when time permits, still doing a bit of security research. So here's the history of the Chrome security team. So I think it all started back in probably 2007 was the first significant event in the life of the Chrome security team. And that was actually an acquisition. Google acquired a company called Green Border. This was a company that had implemented some sandboxing technology, and that actually at the time worked to sandbox the Internet Explorer browser. And the name Green Border comes from the fact that when you would run Internet Explorer running inside this green border technology, you'd actually see the Internet Explorer window with a green border, indicating that there was some extra sandboxing going on there. And of course, our plans with Google Chrome weren't public at this time, but in retrospect, obviously this was an acquisition sort of forming the basis of the Chrome security model, which was strong sandboxing. So Google Chrome itself saw its public launch in 2008, based of course on the green border sandbox technology. Right out of the gate, whilst we were in beta, we tangled with a few security issues, and maybe that was one of the motivations to formalizing a Chrome security team. From the beginning, we've had this role called the security sheriff, and we still have it. And before we actually formalized the Chrome security team, the engineers from the Green Border acquisition are obviously very strong engineers and know a lot about security, so they sort of handled all of the incoming security issues. And in May 2009, I switched over inside Google to go and form a Chrome security team. So I was very excited. And obviously, with just one of me, it's difficult to get everything you want done. So I went to the task of hiring. And it wasn't until October that I managed to actually get a first hire. And as many of you in this room will know, it's just really hard to hire good security people. And the amount of months that have elapsed here between me starting and getting my first hire, just sort of underline that we really are in a situation where it's hard to find good security people. And then it was another, say, 6 months or so before I got managed to get a second hire to bring the team to 3, a gentleman by the name of Inferno, who since then has probably found more browser bugs than anyone on the planet. So that was a good hire in retrospect. And then after those first 3 hires, for unknown reasons, things sped up, and we were able to grow the team quite significantly. So what do we think we've done well in Chrome Security Team? And this isn't a sales pitch, so I'll just go through these quickly, but it's sort of a background for we think we've done some things well, and then we'll go into what we think we did that caused these things. So from the beginning, we wanted to tackle the problem of out-of-date software, which we thought was probably the biggest problem that was causing user damage out there on the internet. So we sort of baked an automatic update process into the browser so that you don't have to worry about whether it's up to date or not. I mentioned the green border acquisition, so we obviously were we think the first browser with a sandbox that fully isolated the file system from potential malware. We've since looked at the threats out there, and there's a few years ago, there's a lot of bugs around the area of Adobe Flash. So across multiple years, we actually pulled that plugin inside the full Chrome sandbox. We also think we're ahead of the curve with the recent Java issues that you may have read about. There's quite a lot of press earlier this year about problems and insecurities in the Java plugin. A couple of years before this, we actually were sort of predicting that this might happen, and we were deploying some defenses in that area, such as user interaction for launching some of the more dangerous plugins. We've demonstrated the ability to do a fairly fast turnaround. Of course, I've mentioned the reward programs briefly already. One of the things I'm most proud of, as L.A. mentioned in the introduction, is some of the technologies we baked into the browser actually caught a very significant incident, which is where allegedly someone in Iran had compromised the DigiNotar certificate authority. I mean, it was for sure that the DigiNotar authority was compromised, and it was alleged that some people in Iran had done this, and that obviously has a lot of safety consequences potentially for people in that area of the world. And we maintain an URL where we try to be modest, but we allow ourselves one URL on our website where we have some unabashed immodesty and sort of a list of things we've done and keep that up to date. Okay, so into part 1. So our hypothesis is that some of the successes, which we've just seen a list of, can be attributed to some things we've done in setting up the security team that are very different to how a traditional security team might be set up. So let's look at these differences. So the way we're going to look at each difference is, first of all, we're going to look at how a more traditional company, or perhaps most companies, might have their security team set up. And the sort of more traditional companies denoted by this icon here, as you can see, we have a suit and tie to denote a slightly more corporate environment. And the first difference we're going to talk about is fix it yourself. So I don't think there's any particular order to these differences, but this one we found we think is a particularly big difference, and we think the benefits that it's brought us are one of the bigger benefits. So by fix it yourself, what do we mean? Well, in this case, let's look at what it means to sort of not do things the fix it yourself way. So in a more traditional security team, you might find that the security team operates most of its time in a consultancy role. So maybe sort of looking for issues, doing audits, and when issues are found, you might just sort of write up a report and we use the term throw it over the wall. That's where you've sort of found some issues, you sort of throw it over to the development team and say, the world's on fire, here you are, please sort out these issues. So that's the security team operating in the consultancy role. Yes?
Could you speak up a bit? Your microphone's not picking you up well, or you could move your mic or something.
Okay, I'm getting quite a bit of feedback.
Oh, well.
I think. Okay, yeah, I can try and speak up, or we can move the mic maybe. So still on the traditional security team, you may find that the type of people employed on a more traditional security team maybe these sort of job titles are weighted more towards analyst or researcher, as opposed to more engineering-like titles. So let's see if there's a different way to do things. So this icon here represents sort of a more progressive way of doing things and the way we've done things in the Google Chrome security team. As you can see, we've lost the suit and tie. We've drunk a bit of Kool-Aid, so we've got a t-shirt here on with a Google Chrome logo on it, and we're all pretty happy as well, as you can see. So here's something we do that we don't often see. So the members of the Chrome security team often actually write code and commit code representing the fixes for security bugs, and we do that ourselves. That's quite a big difference. So we might even find a bug ourselves, and then instead of throwing it over the wall, we'll say, well, you know what, why don't we just fix it too? And of course, the more things we fix, we find ourselves getting familiar with the code base. So as well as just fixing individual issues, we might find ourselves motivated to jump in and actually improve areas where there have been a statistically anomalous amount of bugs. We might say, well, let's just go and help rewrite this area to make it more robust. And knowing the code as we do, we feel empowered to sort of land not just security fixes, but sort of security hardening measures. So one effect all of this has is that you're sort of considered part of the product team. And organizationally, we are actually, if you look at our organizational chart, we're actually part of the Chrome organization, not some dedicated security organization. Most of the people we've hired, the way I put it is we've tended to hire people that are engineers who are passionate about security, as opposed to perhaps people who call themselves security people who know how to do a bit of engineering. And that sort of helps with the mentality where when you find something that's broken and needs fixing, instead of throwing it over the wall, we'll just dive in and fix it ourselves because we like coding, we're motivated to dive in and change the code base. So putting all of this together, we've really found some significant and positive feedback loops develop here. So the more we get our hands in the code and fix things, the more we learn about the code. The more we know about the code, the more likely we are, whilst changing things in the code, to sort of use our security powers, to sort of do a bit of code auditing on the side and find additional issues as we're fixing one issue. So that's one feedback loop that develops. Another feedback loop that develops, we find, is a loop of respect between the security people and the product engineers. So if you look at it from their point of view, they're used to these security people in the previous companies maybe they've worked at who are just sort of throwing problems at them. Here's a bug, this is an emergency, you need to put down the nice feature you're working on and fix this now. And instead now it's like, hey, we found a bug, but we think this patch might fix it. Would you mind helping us review it? And things like this. And we find that suddenly we're not these hated security people that are always causing problems, but we're these people, these engineers, these peers that are coming to them with solutions. And we think that encourages a sort of respect between the two teams. And this respect, we found that it's actually bankable. So the more you do this, the more you fix someone else's bugs for them, the more bank you build up. And then when something really nasty comes in, that's maybe more of a design error than just a bug, and we're struggling to fix it ourselves, we can go over to the engineer and say, hey, would you mind helping us with this? And of course, since we've helped them so much, that they're more than happy to help out. So the takeaway from this is that the closer you embed your security people with the product team, we find that we think the closer you get those two groups, just the more benefit you'll get. And this applies, we think, for all areas of security, ranging from the initial response to the sort of proactive work and so on. So the next difference. So this one's called "It's All Our Fault," and this is a mentality we've tried to develop, and so the corporate guy, he thinks I'm crazy. No, it's not all our fault. What are you talking about? And what that really means is that as a traditional security team, you're really disinclined and perhaps even disincentivized to tackle problems outside of the product immediately at hand. So say you're the security team responsible for product X, there's really very little incentive for you to go and fix things in product Y, because that's, it's not how you're It's not how you're graded at performance review time. It's not what your managers want you to be doing. So is there a different way of doing things? It turns out there is. So our philosophy here is this: we've taken a step back and tried to apply the sort of company-wide, user-focused culture. So when we sort of look at that in the security realm, what we're actually coming back with is that we think that if any problem we see out there is a security problem affecting or harming our end users, we'll just say, well, you know what, it's our fault. We're going to solve this, or at least tackle it. For a lot of the problems, of course, are not yet solved in security. So what does that mean in practice? That's different from what we might do if we weren't thinking everything was our fault. Well, this means that if we depend on any third-party code, even though it's not sort of our fault, our code, our bugs, we're going to go and fix those anyway, regardless of who is the owner, regardless of politics sometimes. And when I say third-party code, of course, a lot of web browsers these days, especially open source ones like Chrome and, say, Firefox, are built on top of a lot of open source code. Since we, pull that directly into our product and embed it, of course, we consider that, our responsibility if there are bugs there. But increasingly, we're looking at sort of non-open source, proprietary, non-vendor, non-Google vendor code that has an effect on the security of the web as a whole. And we're considering, well, the best thing to do for our users is help out getting this stuff fixed. There are some historical user experience decisions in the area of browsing to do with, for example, a lot of security warning dialogues perhaps aren't optimal. We're trying to, although all the browsers behave the same way in this regard, so we're trying to tackle some history there and some legacy there. And you may have seen Adrian's paper earlier at the conference where she's looking at some of the problems with UX and how we can move the web forward there. Including buggy websites. So to give one example, there's still a lot of cross-site scripting out there. And we haven't moved as far along here as we had hoped to, because it's such a big problem. But we sort of say, well, maybe if there's a lot of cross-site scripting out there, maybe it's the fault of the platform. Maybe if the browsers offer different platform facilities, then there'll be less cross-site scripting out there. So we see that as our problem too. As I said, we just try to focus on what the right thing to do is to improve the security of the web. We try to ignore any politics or PR concerns here. And to give some concrete examples, what's in scope here for us to look at. So two main categories come to mind. One is plugins. So we don't, of the major plugins you'll find on the web, things like Flash, PDF plugins, Java, we don't really own the code base for those, but we still try to, where we can, help out secure those. And increasingly in modern times, kernels. So a lot more software these days you're finding is getting sandboxed. And so the attacker has to sort of break your software, and then they find themselves in this sandbox. And then they have to break out of the sandbox. And one of the most popular and in fact, dangerous ways to break out of a sandbox is to attack the underlying operating system kernel. So we're actually, in Google, doing a lot of research to try and improve the quality of both the Windows kernel and the Linux kernel. Both of those products, aren't code we own, but for the sake of our users, it's very important that those two kernels be very solid against security attacks. So if those have bugs, we just say, well, we'll consider it our fault. So we'll put in some resources to try and fix that. Okay, this one's more nebulous, this difference. So we're going to look at it with some examples, but go the extra mile is the difference here. So these are not our philosophies, well they are, but these are, the point of me quoting these is that you'll see statements like this everywhere from every company, from every open source project. So if you go and look up like the philosophy of random project X and try and find their security philosophy page, you'll probably find verbatim a phrase like, we take security very seriously. Has anyone here reported a bug at all to a vendor at all? Anyone sent security issues in? Excellent, lots of you. maybe you got back an automated email fairly quickly, and maybe verbatim it included a phrase such as, "We take security very seriously," after thanking you for your report. So, or maybe security is one of our top priorities is another one. If you go on Google for these quotes, using the quotes to get the exact match, you'll see row after row of corporate website that quote these things. So anyway, the point I'm getting to is this is what we might call talk the talk versus walk the walk. So I mean you have to say these things, right? I mean, what are you going to say? Well, security's maybe 8 out of 10 on our priority list, or we sort of design this and then put security on later. No, of course you're going to say you take security very seriously. So to go the extra mile, you've got to look at actions. What have you done that basically caused you to invoke some pain upon yourself in order to improve security. So that's our philosophy. We'll do something even if it's hard, even if it's painful, or at least we'll try to. So I had a glitch there. So back to the old school way of doing things. So in a more corporate environment, you might find that generally non-security concerns are going to outweigh security concerns. And what I mean by that is say a security engineer has found this fantastic new security defense that really is quite powerful, but maybe it's going to cost you a 10% performance hit on some hotly contested benchmark. I think you might guess, when it comes to the product review stage, who's going to win there. And you often find that if you find a situation where legacy is impeding progress, and that's another case where perhaps you're not going the extra mile, where obviously legacy usually involves old code, painful to change. To go the extra mile, you've really got to sort of dive in and do a lot of work for the benefit that you're getting from security. So what might it look like if you have a culture of going the extra mile? So we've already covered some of this. So tackle others' problems for them. So I think we do go the extra mile when we sort of look at what compromise is going on the web at large. And we see that product Y, where product Y is not necessarily owned by us, is causing a fair bit of user compromise. So what we then do is we'd go and invest some resource in doing some security auditing on product Y and send those bugs along. One thing we found that's kind of painful, but we do it because we think it's the right thing to do, is our sort of posture on once you've found and fixed a security bug, what do you do next? You sort of have the easy option and the hard option, where the easy option is just sort of let that fix get picked up in the product in a couple of releases time when that fix naturally gets picked up in your next major release. What we try and do, and this is painful because there's risk to doing it, but we try and, within a fairly short time frame, grab that fix and backport it so that the user gets that fix to the stable version of the product as soon as possible. And our working sort of goal is a month, which is quite aggressive. But that's a month turnaround from a bug comes in and a user has that fixed in the stable version of the product they're using. And importantly, this applies to internal finds as well. So most of the bugs we find now, we find internally because we've scaled up and have thousands of CPU cores doing automated testing and fuzzing. So we find a lot of bugs internally. And then we're faced with, what do we do with these bugs? And we treat them exactly the same as if we'd received the report externally. So even though they're internal, we declare that we found these bugs instead of sweeping them under the carpet, and we also backport these to the extent possible. And that's kind of painful. We get shouted at a lot by the release managers for merging lots of things all the time, and they know that everything you change is a risk of a breakage or a regression or a bug. So there's a balance there, but we think we've got ourselves a seat at the table to discuss the sort of risk versus reward trade-offs. Spending money is one example of going the extra mile. Like to this day, I don't have any particular budget or headcount limit that I'm aware of, so that's quite a nice feeling. We also spent money on hardware. So I mentioned we do a lot of fuzzing. I think we have in the Chrome team we have about 2,000 CPU cores at our disposal. the wider security team, who occasionally do work for us, they've run up to like 9,000 CPU cores to do testing for security at times, I think. Cover that. And finally, do not shy away from changes in behavior. So no one really likes a change in behavior, because if you change some small behavior, particularly in something ubiquitous like a browser, someone somewhere is probably going to be upset by it. But sometimes changing behavior is the right thing to do. So we sort of, at least the sort of balance we've come to is that we have the permission to sort of, I'm not explaining myself very well here, but we sort of come to this understanding where we're at liberty to try things as long as we don't sort of overstep the line too far. And you know that you have this liberty if on occasion you go a bit too far and break something a bit too significant. And you know, that's happened in the past and we've had to say sorry and scale things back. But okay. So just a brief tangent here on kind of a reflection perhaps on our industry. And also once you sort of understand this comic and where it's coming from, and that it's actually kind of true, it does change your mentality on the going the extra mile we found. So what this is a comic that was published as part of a series of comics by some people on sort of the more, should we say, attack side of the industry. And this comic that they published is particularly interesting. What it's saying is that, you know, in a slightly mocking tone, it's saying to you as some random researcher who's, you know, woohoo, I found a bug, I'm so pleased. They're basically explaining to you that you, with statistical probability, you were not the first to know about this bug. And yet this bug wasn't public. So therefore, you know, this bug was probably out there, known by someone who was using it for a nefarious purpose. And once the reality of this sets in, that we found that it changed our mentality for the go the extra mile thing. So whenever we find a bug, we're like, we've got to do something about this quickly because someone else knows about this bug. So that this drives our philosophy. Time for a bit of a war story, if you like. So we find that it's sort of hard to sort of define go the extra mile unless you sort of fall back to stories about where you think you have gone the extra mile, and that's what we'll quickly go through here. So I do apologize for the sudden and abrupt change of slide style, but I've been sort of mixing and matching decks here a bit. So it's a couple of years ago now, but a company called weve performed what we term a non-disclosure on us. I mean, I don't think it's worth arguing about full disclosure versus responsible disclosure anymore. I think that what you have to be worried about is non-disclosure. So that's where, back to that comic, that's where someone's found a bug and they're not telling anyone about it. Because, you know, they want to use that bug to make a lot of money, which in turn implies that there's something not good going on with that bug. So non-disclosure is what we worry about. And in fact, if someone full discloses on us, we're delighted because it's something we can then immediately fix, which is perhaps a turnaround from more traditional thinking again. Anyway, so this non-disclosure was a partial non-disclosure, I suppose. The form was YouTube video showing an alleged compromise of the Chrome browser, but obviously zero details that would permit us to go and fix that bug because that's not the business model of this particular company. What would a normal security team do? Well, you know, this claim is just a video of like a calc popping up, pretty much, which is a completely unverifiable claim. So you just ignore it. You know, go away, please. Come to us when you want to share openly with us security research. You know, hand it off to your PR team to sort of bat down the reporters who are, you know, trying to make a story out of an unverifiable claim. What did we do? So we thought, well, let's take this seriously. I mean, what can we do about this, even though there's no details of any use whatsoever? So this is a freeze frame from the actual YouTube non-disclosure video, showing, I don't know if you can read it, but there's some text inside the Chrome window itself saying your browser is being pwned. Not long after, and something's going on in the background. Not long after this, in the video, I think a calculator pops up, which is, you know, the industry standard for demonstrating that you've compromised a browser. So what we did is we sort of did a frame-by-frame view of this video to see if there was any information leaked. You know, all of us were sort of crowded around a machine for a day trying to work out if we could get anything out of this video. And this particular frame is quite instructive, we found. So it says that I've zoomed in a piece. I'm not sure how well you can see it, but so behind the Chrome window is the Windows Task Manager window. And the reason that's been left up is to sort of demonstrate that they've broken out of the Chrome sandbox. And as it happens, you can see the Chrome icon there. And just above the Chrome icon, you can see a couple of pixels of gray for sort of the sort of program entry, if you like, above the Chrome icon. It turns out that's a significant info leak. Just that, it really is just 2 rows of pixels. And that's a significant info leak. The only way you'd see that icon is if you've launched our Adobe Flash broker process. So immediately that's telling us, well, we think this might be a very significant information leak. We think it might be pointing to a bug, not in Chrome, but actually in Flash. So is there anything else we can ascertain here? So the integrity level is shown in the Task Manager. Fortunately, one of my team members was at the time an expert in this process viewer piece of software, and he happened to know that there's a bug in it where it mislabels something in this column. So he was able to deflect sort of what would have sent us down a false path and tell us, yeah, something here is mislabeled. And so once we'd worked that out, we were able to look that there were 4 Chrome processes there, and the way they were sort of, the relationships between them again indicated a Flash plugin launch. The third thing we noticed is that for some reason the memory usage of the process is in view, which is interesting, and it's about 0.5 gigabyte, which is huge. That tells us that there's some form of spraying exploit going on, so that's another leak. And also just the position of the scroll bar on the Chrome window shows that there's some unshown content there that's causing a scroll bar to appear, and that's also indicative of what you might expect if you've got an invisible plugin rectangle there. So all of this gave us confidence that, well, it's a problem not with Chrome, but with Flash. But linking back to our early principles, you know, we're going to call it our fault, because if we can help, we will, even though it's not necessarily our code to go and fix. So we have an employee called Tavis. Has anyone heard of Tavis at all? He's one of our strongest security engineers. So we borrowed him to go and do some work on Flash security. So and we lent him a little bit of resource to help him out. So he used about 2,000 CPU cores to perform a fuzzing technique that he'd pioneered a little earlier, which is where you sort of, what you're trying to do is do some fuzzing with excellent code coverage. And to do that, what you can do is you can download a wide sample of input files and sort of crunch them down into a corpus of files that is a minimal set of files, but represents the maximum code coverage you can achieve. Unfortunately, working at Google, you can access a lot of scale, not just these 2,000 CPU cores, but also, you know, a copy of the internet. So what he did is he took a copy of the internet, and from the internet he extracted and many terabytes of Flash files to perform this analysis, and he crunched this huge set down. I think the input, 20,000 files, I think I'm not sure if that was the input set. No, that must be the output set. So I think maybe there were like millions and millions of Flash files he crunched down into this quite dangerous set of 20,000 files that represents very good code coverage whilst being a good basis for fuzzing. And anyway, he sort of then used the same 2,000 CPU cores to crank out about 100 unique bugs in Flash. And obviously we worked with Adobe to get those fixed. Also, we thought, well, this is an opportunity to improve our Flash sandbox. There's obviously some deficiencies there, so we sort of patched things up best we could in the short term, including, we believe, the sandbox escape used in this exploit, because it was quite discoverable, so it was likely to be the same one that was used. We later got confirmation unofficially that it was. And we accelerated work on what's known as Pepper Flash, which is long since now, and which is now long since deployed. Maybe it's been out there for a year, but it's basically the act of bringing the Flash plugin inside a sandbox of the same strength as the core Google sandbox, which we think is one of the more significant security improvements we've done in the multi-year lifetime of the team. And we also went on some hardening measures. This is one of those incidents where I mentioned we have the leeway to sort of step up against the bounds of what a security team can do and go beyond it. And this is one instance where we went a bit too far in our enthusiasm to respond, and we actually regressed, functionally regressed the Adobe Flash plugin in Chrome, in quite an amusing way, if it's possible to annoy people in an amusing way. What happened is we put a limit on something called JIT pages to try and limit exploit potential. And when the limit hit, which we thought it would not do, we popped up, what happened is a little dialog box would pop up with the hex string, a bad idea in it, which is a bit cryptic, but we would recognize it, right? And we certainly did start recognizing it when people started blogging this strange dialogue that was appearing when they were just trying to do something in Flash. So we had to back off a bit there. But yes, that's a bad idea in hex. Sorry if you saw that. And finally, we'll get a bit more to this, but we invited the community to rampage on Flash as well by bringing Adobe Flash under the umbrella of our reward system. So if you find a Flash bug, feel free to send it to us, and you may get a monetary reward if it's significant for security. There we go. So next difference. So security is not a zero-sum game. So that's more of a statement than a difference. I suppose the difference is that we genuinely believe that security is not a zero-sum game, which is to say, let's look at the traditional view of security. If you think security is a zero-sum game, you think that you can win security at the expense of others, by doing something and then not sharing it and saying only we have this protection. Or you might treat security as just a PR game. We'll just say how awesome we are. Maybe it'll set in as a mindset. So, and at some companies, collaboration may, even in the security space where collaboration I think is quite important, may even be discouraged, filtered, or even outright just banned because because of concerns about confidentiality maybe. Is there a different way of doing things? Well, yes, of course. So we really do within the team encourage collaboration openly and freely on security features and standards. We currently have a few standards we're working on that are just about final call at the IETF level, I think, for certificate authority related hardening. We really do like it when we can share experiences and approaches such as this talk with other vendors, and even since we're an open source project, we have the liberty of sharing our code if anyone wants to come borrow it. They're welcome to do so. We've had several projects borrow some of our sandboxing code. And this one surprises people perhaps the most on this area, but we actively support any employees that want to research non-Google products, even if they want to do it in their work time. To give an example of where this makes sense and has had a lot of benefit, I've mentioned that we've got a lot of fuzzing infrastructure and a lot of CPU resource we can dedicate to that. So once you've got the infrastructure running against a browser A, like Chrome, our browser, it's actually fairly trivial to briefly point these 2,000 CPU cores of security fury at any other browser. And we sort of from time to time do that, and because it's easy to do, and because that results in quite a few bugs against all of the browsers, and we sort of send those along so that so the whole web can get safer. So we definitely believe where security is concerned that the whole not a zero-sum game antithesis is that a rising tide will lift all boats. So that if we can make the web safer for everyone across all browsers and technologies, then people will use the web more, and that's good for us as a company. Next difference, so remove the middleman. So depending on which company we're talking about, security response can be done very differently to how we do it. So I made an attempt at drawing a diagram of a more traditional way of doing security response. I was hoping to crib one from the internet, but I drew a blank actually, so I had to draw one myself, and I'm leading in here because my drawing skills are pretty bad, so I apologize for the state of this diagram. I'm not even sure if you can read it, but it's an attempt at a flow chart of how of how security response often works. So I'm just going to run through like this process a bit, pretending I'm a security researcher who's found a bug and I'm reporting it to a company who operates a bit more like this. Feel free to raise your hand if this sounds familiar to an experience you've had at any time. But, yeah. But anyway, so woohoo, I found a bug. I'm going to report it because it's the right thing to do. So I send the bug in, send an email, and immediately I've got an email back. This is awesome. Well, it's an automated reply, which is less awesome, but it says that, you know what it says? It says we take security very seriously. So I'm all fired up now. And a day later, I get a question, some clarification on how to reproduce the bug, perhaps. So send an email back, and I get an email back a day later, and we've worked out how to reproduce it. So the next thing that happens is internally, maybe it's a fairly tricky bug, and the organization who's responsible for triage are security people, but they're not necessarily expert in all domains, so they bounce this bug over to their internal expert team, which is a central resource, who then have some more questions, so that sort of bounces back through the response organization to me, and I try and answer those questions, and then eventually, internally, the bug will get sent over and filed with the product team, who may or may not have some questions again. They may consult some internal security experts on how best to fix something, particularly if it's not just a bug, but a design level flaw. Internally, then a three-way disagreement may kick off on the severity of the bug, depending on the product team view versus the security team's view versus what I've claimed as a researcher, and so on and so forth. So, a week later, as this internal argument's going on, I send an email saying, hey, what's up? Are we going to get this fixed? So, the response org will then harass the product team for a status update and then sort of filter it and send it back to me, and so on and so forth. So a lot of communication going on. What I've failed to draw on this diagram is perhaps a big red line towards the top of the diagram across sort of the top couple of boxes. And the point there being I only get visibility into a very small part of the process, and all of this sort of internal discussion about the bug I found is hidden from view for me. So what might be the problems of operating in this sort of manner? One is just latency. So just the sort of round trips going on between people that I don't get to see and get involved with. Latency means that I won't get status updates as often as I might. Just every day that there's latency going on, that's a day that the fix gets kicked out. Like users will get fixes later, we think, because of this. Significant potential, and I've had this personally, for what I call lost in translations. It's where you sort of have this middleman who's your sort of case officer, if you like, who understands security, but not maybe perhaps as much as the technical person who's actually working out how to fix the thing. And you're not having a conversation with a technical person, you're having a conversation with this middleman, so it can be quite cumbersome sometimes. It makes it hard to have technical discussions sometimes. Significantly, I'm big on collaboration, and I think the sort of opacity of the process that I alluded to, you don't see a lot of the discussions going on regarding the bug, mean that you can't sort of chime in and help. Some bugs, especially design level bugs, are kind of hard to come up with a good fix sometimes that's both secure and also doesn't break the world. So sometimes being able as the researcher to be involved in the discussion on how to fix something is nice. So we think we've removed the middleman. How does it work? How might something be different? So to report a bug against Chrome, you go to our bug tracker, and publicly accessible on the Internet Bug Tracker, and you file a bug, and one of the options is this is a security bug, which obviously will restrict view from public and notify us. And then we find that for the more interesting bugs reported by the more interesting researchers, usually on the same day, like this, a three-way, often high-energy, exciting conversation kicks off in the bug tracker. Between the person who sent us the bug, between a member of the Chrome security team, and perhaps also the engineer who's probably the best to fix this issue. And going back to one of our earlier principles, that the engineer fixing the issue and the Chrome security team member in a lot of situations will try and make that the same person. And on this bug, additional experts in the area or in the code base get CC'd to keep the conversation going. So what does this lead to? So it's definitely low latency. So on occasion we've had a bug come in, and the same day we've landed a fix in the code base. That's not the same as getting the fix to the user, of course, same day, because that would involve perhaps rushing something without QAing it, and we don't do that. But some of these same-day fixes that we do inspire people to comment in the bug tracker, oh, that was fast, and that makes us smile when we see things like that. And I just did a scan through the bug tracker for fast, and you can find lots of bugs where this has occurred. And this last bug that's just popped up here, these are all public, you can go and read them, of course. This is an example of where the researcher also sort of bounced ideas off us, and we bounced ideas off him, on the best way to fix the bug in question, and we came up with something that everyone was happy with, and then we fixed it. I think our total turnaround time there was about 5 days to get the fix to users, which we're not always that fast. It was a fortunate coincidence of release cycle timing, but it illustrates that with this process you can get very low latency through the system. And then, of course, we gave the gentleman a monetary reward at the end of things. Be transparent. So we have a sort of an advantage, I guess, in being an open source project in that we're fundamentally transparent, but I think there are some transparencies that companies with closed source products could engage in that don't necessarily require being open source. So if you're not being transparent, how might you behave? Well, often in my dealings with vendors, I often find that it feels like communication with me is minimized to the bare bones of what can be said. I've thought long and hard about why this could be. And maybe I just don't know. Maybe companies are concerned that anything they may say externally might end up getting quoted, which it might, and might end up in some news story, perhaps. I don't know. So perhaps there's some sort of trade-off balance going on between the risk of saying too much versus the risk of limiting collaboration by not saying very much. If you're not being transparent, you'll definitely, when you find bugs internally to the company, you'll keep them secret. And you'll fix them, of course. But when you do so, you won't necessarily announce that the bug has been fixed. And that's probably relating to the fact that you won't necessarily backport the fix. So if you announce the fix against the latest product, you'll be expected to backport it. So this sort of lack of transparency might be considered dangerous for security. And when you do announce something's been fixed, so I'm just going to get a time check on. Oh wow! All right, 10 minutes left. So you may find that when your company does announce a security fix, they'll announce it in very broad, a-specific terms, and they won't necessarily share the full original report that caused the fix. So is there a different way of doing things? Well, yes, we think so. So we've mentioned that to report a bug to us, you just file it in our bug tracker. But that's just the start. So all of our security bugs are tracked in our public bug tracker, and that includes stuff we find internally. And we really do enjoy making all security bugs after some suitable period of time fully public. So you can go back and look at the history of any security bug in the history of the product and read that bug. Of course, sometimes we delay opening the bug for public view because a lot of the code we use is shared with other products that also need to take their time to update. We say bug tracker and bugs, but I think if you look at a given bug on Chrome security, it's more than just a bug. It really is a conversation. You sort of see collaboration going on, and you can see discussions about how the fix should be implemented. You see the researcher jumping in from time to time who's reported us the bug, who to sort of add something and help us, and it's only the transparency that lets us do that. And I don't know why more people don't do this, but we really think there's some real historical gems available in our bug database. So, for example, we have our competition format called Ponium, where we actually, for a large sum of money, we require people to actually exploit bugs instead of just find bugs. And, of course, the principle of transparency dictates that the full working exploit that did work at some point in time is just there as an attachment to the bug, and you can go back and look at those and study them and learn from them. And we're quite pleased that some people do go in and study these exploits and then write papers on the techniques used and so on. So we're quite pleased about the open collaboration that is encouraged there. And the best story I could find, which demonstrates why transparency is a huge win for us, is just some other bug. The numbers are just some random number, but it's public, you can go and read it. And what actually happens is a researcher sends us a bug, it's a very good bug, and we fix it. And within a day or two, the researcher comes back and puts a comment on the bug, and what he said is, hey, I don't think you fixed it properly. There's this sort of corner case that still seems to work. And what that enabled us to do, and of course our transparency was what enabled him to tell us that, what that saved us the pain of is it saved us the pain of sort of fixing the bug, releasing it, and then him coming and saying it's not fixed. And that would have been kind of embarrassing, when you don't fix a security bug properly. It's like, oh man. But what he enabled us to do is get it right first time, which is awesome. And of course we then promptly doubled his reward because we said, well, we think this counts as 2 bugs. We'll just pay you twice as much for your help. Very briefly, another story. The reason we have this story is some people, I think, often in security there's a fear that transparency will lead to the possibility of attacks against you. Like if you have all of your dirty laundry out there for public view, the fear is that someone can come and sort of count how many bugs you've had and say, oh my goodness, that's so many bugs, or someone can start reading through your bug database and saying, oh, that was an awful bug. But, maybe that's true, maybe there's a chance that will happen, but we think that the benefits of open, transparent collaboration outweigh the risks of taking a sort of some PR hit. And actually, we found that being transparent can be very PR positive in this recent incident. So we posted some blog post, unrelated to Chrome really, that someone disagreed with and had a counter opinion, which is awesome. However, the way they sort of framed their counter opinion was around this claim that they had tons of critical Chrome issues that were months old and had not been fixed. Obviously, that's a fairly inflammatory story. It might get some traction. So we thought, well, we'll look into this. And we found that actually this was not true. There were some bugs that had been reported, but they were sort of, in our opinion, not security bugs. So because we're transparent, we were able to respond by posting this link, which is just a query in our bug database for the name of the company that had made this claim, listing all of the things they had reported, enabling anyone who wants to independently verify our claim versus their claim. And in the end, the story blew over. More than that, in fact, the blog post making the claim was taken down and sort of modified to be a little more true. So transparency here was actually a PR win. And this is the final difference. Again, perhaps one of the ones where we think is more significant to our story, and that's celebrate the community. So a more traditional company has been known to sue the community. There have been reports of this. May attempt to vilify members of the community if they don't see eye to eye on the severity or timeline maybe of some bugs. It doesn't seem excited to work with the community. May try and downplay the significance of researchers' research and so on. So as a principle, we found that the more engagement we do with the wider community, just the more awesome it gets. So we really try and celebrate community contributions as much as we can. So we have a Hall of Fame which lists everyone that's got a monetary reward from us, and also everyone that has not quite crossed that bar but has still sent us something useful. So we have a list of people, and we just try and say, hey, this is a list of people and they're awesome. And we get feedback that's helped people land jobs. Sometimes with us, actually, but also with other companies. So that's quite appreciated. Whenever we fix something that someone brought to us, we declare it in our release notes. Just respect. So part of the transparency principle we saw earlier, it also is more sort of, it's like contact with the Chrome security team is also less mechanized and more individualized and humanized. So when a researcher comes to us and there's this bug and it's something we just haven't thought of and we think it's really clever, you'll see myself or one of my engineers, the first response in the bug from us is, wow, this is an awesome find. This is really clever. How did you think of this? And we just find that sort of one-on-one researcher to researcher interaction gets a lot of respect on both sides. Of course, we celebrate contributions financially on a per bug basis. Just because we can, sometimes we decide that someone has been so awesome, we'll just issue a surprise monetary reward to them, like sort of a best of the best for the year kind of reward maybe. And also when we get something sent to us that's very spectacular, we'll often do a write-up ourselves as a celebration of the quality of the work. So some of the podium entries we've received, we've actually written them up and published them on an official Google blog to celebrate the researcher's achievement. So this is, the next couple of slides are not new rewards, but this is just to illustrate that sometimes this was last year, we just randomly decided to give a couple of our top reporters an extra $10,000 top-up just for working with us and sending us such awesome stuff. So a couple of slides from a presentation I did last year where we'll just give these two awesome people $10,000 each as a top-up to the extra other rewards they've got. So that ends part one. I'm just going to do an exact time check again with Ellie here to see how much part two we want to get into. 5 to 10 minutes. Okay. Are people enthused to go into some more detail in our reward program? Or anyone? We'll dive in and see. So this is the story of Google's history with rewards. This is where when we get good security reports in, what we'll do is we'll financially compensate researchers that have sent us those rewards. So we'll start with the statistic that people are usually most excited about, which is, of course, well, how much have you paid in total? That's the first question we usually get. And some breaking news, or at least it was new on Monday when we did a blog post about this. We're now up to 2 million USD across our various reward programs. We've crossed that bar. And interestingly enough, that is split down almost equally, $1 million each, from the sort of Chrome, Ponium side of things and the Google website side of things. And I suppose I should admit that internally there was a bit of competition to get to $1 million first. I was rooting for Chrome and I lost, but we crossed $1 million just after. And that's a lot of bugs as well for that money. It's about 2,000 bugs across everything, slightly skewed in favor of more bugs on the web side of things, probably because we have a lot more websites than you would think, and maybe it's a little easier to find certain classes of web vulnerability than it is to find a memory corruption in a browser. There's the blog post we put out about that. Oops. A small glitch. Okay. Every time I talk about the rewards program, the goal of it changes, of the talk changes. So at first, the goal of the talk was just say, hey, we've done something a little bit different and a little bit crazy. We're just going to tell you how it went, just to share our story. And now, over time, things have changed dramatically. We now give this talk to try and tell people, just engaging the community in this way is just 100% fully positive. It's awesome. It's exceeded our wildest expectations, and you should launch a vulnerability reward program, if it makes sense. And there are a couple of caveats we give here. So one is a you must caveat. So if you or your company are responsible for software which is sort of what we call frontline in the malware fight, so installed on a wide percentage of the world's computers, or part of critical infrastructure, the world depends on you. It sounds dramatic, but the world does depend on you if you're in that position. And one way you can make your security posture better is to have a reward program, and you should. But before you do that, you want to have a mature SDL in place. Like this reward program is not a substitute for not bothering with security. And in fact, if you haven't bothered with the security and you launch a reward program, probably you'll be overwhelmed. So you need to have your response organization sort of finely tuned and well staffed, we say. So the history of bug bounties, best we can trace it back. We think that a gentleman you may have heard of by the name of Donald Knuth may have kicked this whole thing off in 1981 in a slightly different way, but if you found a quotes bug in his book, he would send you a check. I don't know, has anyone here got a framed check from Donald on their wall? You do. I knew I'd get a hit in a crowd like this. Excellent. And then, of course, the first significant vendor to do this was probably Netscape back in '95. When Netscape became Mozilla, they carried that on in 2004, and so on and so on. And as you can see, the sort of packing density of these program launches is getting more dense as we go towards modern time, and that's as more and more sort of fact-based, or just more and more facts and data out there that this is a good idea, so you see more and more people doing it. Since I wrote this slide, which is now very old, a bunch more companies that you've probably heard of have dived into this game because it works so well, including most recently Microsoft have dipped their toe in the water, and I think that's fantastic because they sort of count on this, some of these goals here. They definitely count on being frontline in the fight against malware, so the fact they've done this is awesome. Some history. I think we'll skip this slide because we're low on time, but this is just showing how over time we've ratcheted up the reward levels. And in some way, you can see these reward programs as an economy. Over time, it gets harder to find bugs. And so what you want to do, perhaps, if you're serious about these programs, is as the incoming report level trickles down because it's getting harder, you have this big knob you can turn, which is, max payouts. You turn that up, and that remotivates people. So you found that over time, we've done quite a few reward increases. Another question we get is, what does it look like when you launch a program? This is the Chrome launch. We actually launched in, I think, January 2009 at the beginning of the graph. So in terms of months elapsed, we had a pretty slow ramp up for people engaging with us. It wasn't immediate, but it did happen eventually. So maybe that's a reflection of the fact that researching a browser can be quite hard. You need to sort of invest a lot of time to learn about a browser before you can necessarily dive in and attack it. Oops. History of Ponium, our competition format. We sort of dipped our toe in the water by sponsoring a top-up reward for Chrome at an industry competition in 2011. The year after, there was a misunderstanding, so we'll just launch our own competition. And we've tried to calibrate things again. Looking at this as an economy, we tried to calibrate things so the reward was high enough that someone was sure to enter, and we got it just right, and we got some entries. So a gentleman by the name of Pinkie Pie won $60,000 for the second competition. That's his logo. Ponium 3, he didn't quite get the full prize, but he turned up and took a $40,000 win. And the first one we had, he turned up for a $60,000 win. It's getting a bit tedious at this time, so he's sort of our benchmark. One day, if we run a Ponium competition and he doesn't show up to collect his $60,000, we know that we're in really solid shape because this guy's amazing. And skip that. So just to humanize the whole Ponium competition, here's something we know. So that's me with shorter hair, with the red T-shirt. This is the sort of tense moment around the desk where someone's turned up and they're like, I can do this. I've got this website when you visit it that will compromise Chrome and for my $60,000. So all eyes are on the laptop. And you may notice there's a guy sort of in the background to the right-hand side, and he has a look of abject terror on his face. I don't know if you can see it. It was blurry enough, but he looks terrified. And the reason for that is we actually had, in this competition, the Adobe Flash plugin in scope. And this gentleman is an employee of Adobe, and no one quite knows what's going to go down yet. So there's this thought, he's probably thinking, oh my God, please don't be a Flash bug. Just don't. And it wasn't. So I don't have the picture to prove it, but he's looking a bit happier about 5 minutes later. So I've talked a bit about how we think we've had some successes. We also don't mind poking fun at ourselves if we fail. So the Ponium 2 $60,000 win involved 2 pieces of attack against Chrome, like a difficult piece to sort of break into Chrome. And then the way this gentleman, Pinkie Pie, broke out of the sandbox was just too easy by our standards. We set ourselves high standards, and we weren't very happy with it. Of course, best foot forward. We made some changes to make sure it shouldn't happen again. But we definitely earned a double facepalm for our performance here. The way he broke out of the sandbox was he found a way from within the sandbox to request the privileged context to just write this sequence of bytes to this file name, which is not a good property to have in any sandbox. And it was so bad, we just went to meme town with this. It's like, a meme about trust. Oh, we're just going to trust the file name, the file path, and the content of the file. That's a great idea. So long since fixed, and we also went on an internal audit rampage to make sure there were no other instances of this after this happened. But that's why we do the Ponium competitions, and that's the value they provided. We really wouldn't have found out about this if we hadn't done this. So it's best $60,000 we've ever spent probably. just shout Ellie if we need to stop. But just briefly to go into the other main reward program, the Google Web program. It's more contentious because this is the first time we know of that a large corporation was going to put up security rewards relative to a live production website. There's no other good way to do it, really. So, you have to talk to your legal people, talk to your budget people. You have to get buy-in from thousands of teams instead of just one product team. The most interesting thing people want to hear about is legal. Our lawyers were awesome. It turns out that if something's illegal, you can't make it not illegal just by writing a blog post. I mean, if the world worked like that, I think we'd see a lot of trouble and a lot of blog posts. So you so you don't lose basically the right to go after criminal activity by having a bounty program is the legal principle here. Also, as long as you have clearly defined do this, do not do that, you also don't lose the ability to chase people civilly if they've really tried to damage you. So legally, actually, it turns out you thought it would be a headache, but that was just fine. And for this launch, we formed a formal war room. Right? So we have our finger ready to go on the blog post saying, hey, we're paying for bugs in Google websites. And we're all sat there in the war room, and we don't know what's going to happen. So we had a sweepstake on how many bugs we'd get in the first 24 hours. And I said, maybe a few. And I lost. I lost to someone who said something more like, yeah, maybe a fair few, maybe a lot. We'll look at a graph in a minute that illustrates that. So quickly, the eligibility. Before you launch a program, you want to publicly document very clearly what is and is not in scope to avoid any misunderstandings. So we did that. We actually exempt acquisitions for 6 months after we acquire them, because when you acquire an acquisition, they may not necessarily have the same security posture you do. So we think it's reasonable for us to hold ourselves to a standard of beating them into shape within 6 months. Challenges, we're worried about a few things before launch. I can go into these in the Q&A if you like, but none of these challenges or worries came to be true. So this graph, so we press the button. Can you tell at what point in the timeline of this graph we launched the reward program? I don't know if you can actually see it, but there's a there's no Y scale, I apologize, apart from being relative, but you can see this is a graph of bugs filed due to external reports per week, and there's sort of a small dribble of bugs coming in the first few weeks represented on the far bottom left of the graph. And then, bang, that's me losing my bet. So our takeaway from that is that it's easier to immediately dive in and do some website security research than it is to do browser research. Another takeaway is, if you do this, you want your response organization primed and ready. You probably want it overstaffed such that there's spare capacity beyond the current level you're handling. To sort of put some numbers on that spike, it's actually a 10 times spike in incoming reports directly after launch. An order of magnitude, so it's quite interesting. It then settled down a bit to a 5 times load for several months, and we think it is steady stated at about 3 times the load of what it historically was, which is much more manageable. Just to show you a graph illustrating some of the economies of the situation. This is obviously old now, but when you first launched, you sort of had a load of stuff come in, and then it sort of drops off in. I didn't mathematically model this, but it's probably it probably maps to an exponential decay, perhaps. I don't know, but it shows you that you launch a program and it's easy to find bugs, relative, and then over time it gets hard to find bugs, and that's when you might consider bumping up the rewards. We had asked what type of bugs people find. XSS, which is the blue chunk as a percentage, dominates the number of external reports, which is probably no surprise to those of you who have researched or administer websites. This is kind of cool. When we launched the reward programs, our philosophy initially was that, well, we really love working with the community, so the reward program is a thank you for work you do. But turns out having a reward program will attract new researchers. In fact, about 85% of people submitting bugs are new versus the 15% of researchers that we used to work with before the program. Geodiversity, Only 13.6% USA-based, the reporters, which is kind of interesting. To go into more detail, we have significant geodiversity. Just a random list of countries here from which we've had people come to us from. I put Finland in bold because there's just something about Finland. I don't know, is anyone here from Finland at all? No, I can't delegate that one to the audience, but on the Chrome program, of everyone that's turned up, there are 3 people from nowhere turned up from Finland, not really knowing each other, just 3 random unrelated people from Finland, and just sort of, and tore the house up. They just made a lot of money and sent us some awesome bugs. Just Finland. The mystery will have to remain unsolved, I guess. How charitable are the... moving on. So yeah, the results. You get that immediate... You get an immediate spike in reports. The signal-to-noise ratio was better than we thought. We thought we were going to get some people who only had a peripheral understanding of security come to us and try and make money for non-security issues. You really get a coverage that you just don't get with your internal security team. Let's say you've got an internal security team of, I don't know, say even something big like 100. How can you compete with the tens of thousands of security researchers around the world, both in terms of breadth of coverage, but also in terms of just sort of thinking of all the corner cases. So you're getting some really clever stuff if you launch to the wider community. We've got in some fun bugs as well. So this is one of the most serious security bug I've ever seen. So this gentleman claimed that if you went to translate.google.com and specifically tried to translate from Portuguese to Spanish and specifically type in a long sequence of P's, the security bug is, it sounds just like a helicopter. I was on the rewards panel for the web program at the time. I voted to reward him just for being awesome. I was shot down by some other members of the panel. Perhaps they had a tie on like the icon I've been using earlier today. But yes, I'm not sure we fixed that one either. Which is obviously a very bad response time. This came in several years ago. So summary, positives. So it's hard to objectify how much more secure you've made your users, but the only good way we found of doing it is we talk to the people who send us issues regularly, and we just sort of shoot them an email every month, or if we haven't seen them for a while, we're saying, hey, is it getting harder? And they're like, yes, it's very hard now. In fact, I'm going to spend my time doing something else, it's so hard. So, if you launch one of these programs, you really can sort of flush out the corner case bugs that your normal security process might have missed. And everyone's human. We all miss security bugs. Thinking about the sort of darker side of our industry, we've actually, through unofficial back channels, verified that we've had what we call collisions. So that's where a white hat researcher whose intent is to make the web and the world a safer place has sent us a bug and we fixed it, and that has collided or stepped on the toes of a more nefarious intent. Someone who also knew of that bug, going back to the earlier comic, and goodness knows what they're doing with it, but by motivating the community to step up here, we actually do make a dent in the darker side of the industry. No O days is just a reflection of the fact that since we launched the program, we've not really had someone drop a Google XSS. We used to have people say, lol, I found a Google XSS, and we'd scramble to fix it. Now it turns out that a few $1,000s is more fun than posting to a message board. Relationships with the new people. We've actually hired a bunch of people specifically through introductions made on our reward programs. Obviously, a security hire is always difficult, so we're really pleased about that aspect. Cost effective. There's a paper by Dev that was presented earlier in the conference, tried to sort of objectify some of the cost effectiveness, which is awesome because we just wave our hands in the air and say it's really cost effective, and the paper comes up with some figures like maybe 10 times more cost effective than other ways of getting the same results, and so on. Oops. Negatives of launching the program. I mean, it's a flippant slide, right? But we racked our brains to try and think of anything that went wrong, and it's just all good. just so that you try and persuade you that it's not just me ranting up here. Others who have jumped into this reward game have been positive on it. So, ranging from the PayPal CISO, who freely admits that he had reservations about the whole concept, but then data, and the keyword being data, has proven him wrong, so that led him to launch their program. And down at the bottom, Etsy, their security lead, says what I also believe now, that this is industry best practice. So I think we're heading rapidly towards a world where any company who has significantly important software and does not have a rich bounty program is not following industry best practice. Recommendations, you should launch. If you do want to launch one of these things, you've got an open invite to lunch with myself and others at Google who've done it before. You might want to start small if you're a bit nervous about that 10 times spike. So you might want to launch against a subset of your products. We've covered having your response machinery primed and ready, and proactive communication of what's in scope. Remain respectful. We recommend paying for issues in pre-production versions of your software. It's kind of obvious if you think about it. Would you rather find out a bug before you launch it to your users, or after you launch it to your users? And I hope I haven't gone over too much, Ellie, but at that juncture, I'd love to invite any Q&A you have.
Alan Sherman, UMBC. How does your security team interact proactively with the design of new products from the very beginning of the design phase?
Yes, that's a great question. So the question was about how we handle design reviews. It differs across the company, but I'll talk about from my perspective on Chrome. What we do is we have a formal launch process for new features, and security has a seat at that table. So when someone's thinking of doing a significant new feature, one of the teams they talk to is security, and at that time we immediately look to see if this feature carries a lot of risk, and if it does, then we'll assign some dedicated security people to actually sit in on the design meetings and be co-authors on the design docs, so that we have confidence that at the design level things have been done right. And as I'm sure was implicit in your question, if you mess up the design level and find out about problems later as you're getting close to launch, that's a really horrible situation to be in, because you may even be faced with launching with security issues or sort of delaying by months the project.
Chris Watzak, Georgetown. I think your good neighbor policy is a really good one, so you kind of go above and beyond to solve other people's problems. But do you get tired of solving problems in Flash, and do you reach out to Adobe to try and figure out if there's a better way to solve that problem?
That's a good question. So do we get tired of helping other people out? I mean, the answer is no, because we enjoy enjoy finding security bugs, especially ones that may have a positive impact, not just on us and our users, but the whole web. In terms of getting tired of specific projects, what we do try and do is we do try and automate such that we have computers on the task, and they rarely get tired in the way that humans do. So, for example, for some of the work we're doing on Flash and a lot of our own internal code bases, we have ongoing fuzzing that both will detect regressions and also sort of tirelessly flesh out the corner cases of bugs.
Hi, I'm Eric Ide from the University of Utah, and actually that was a good lead into my question. So I'm active in fuzz testing, and I'm interested to learn a little bit more about the fuzz testing that you apply. This is maybe cluster fuzz. Could you say a little bit more about that? And
yes,
yeah.
so our fuzz story, you mentioned cluster fuzz, which is the affectionate name we have for our 2,000 CPU cores. So to be effective at fuzzing, we find you have to do several things. One is scale, which we think we have covered. Although there are plans to bump up the number of computers we have on the task. The second is picking your targets. So you sort of have to know which areas of your product will benefit from fuzzing, if you like, and what type of fuzzing. So there's more than two. The third thing we do is we try and start simple and then get clever. So for something, we talked about flash fuzzing. So we started simple on Flash, which is we've got a large corpus of 20,000 files we mentioned, but the mutations we applied to sort of the files to try and find security bugs were not particularly intelligent. You know, you just start flipping bits here and there and see if you get crashes. So what we do is we start simple and sort of fuzz hard until we've sort of got all of the crashes we think that we can find with simple fuzzing. And then we get a little more creative, like, you know, we'll write more intelligent fuzzers that understand more about the structure of the file format, so they can perform mutations that are sort of surprising to the piece of code parsing the format, but are not actual violations of, say, the specification that would, you know, cause the parse to just stop. And we're also then, you know, sort of keep going in that direction. We then look at grammar-based fuzzers that sort of don't rely on existing test cases, but sort of generate from scratch, you know, some sort of slightly off test files along the lines of what the program is expecting, but you know, a little bit surprising.
Drew from NEC Labs. So I'm quite interested in the number of security engineers that are in the Chrome team, or more specifically, what is the ratio of security engineers versus the rest of the team?
Yes, that's a great question. So it's about how many security engineers we have. So I'll give you a few numbers. Fortunately, we're not quite as secretive as some companies, and we do give out some numbers in this area. So company-wide, the number of security people we have is hundreds and hundreds and hundreds. I don't know it as a percentage of engineers. I know that there's an industry recommendation of about 1%. I know that we're significantly above that by choice. In Chrome, I can maybe give you some more specific details. So the Chrome security team itself, depending on how you count, is about 20 people now, which we think is a reasonably staffed team for just one product. And it's not just 20, actually. It's more than that. So we have, aside from the 20 security engineers we have experts in SSL and certificate authorities that are not technically on my team, but the technical and the network stack team, but 100% of their time, day in, day out, is you know, security-related features and enhancing things. So maybe I don't know, maybe the number's 30 as a percentage. I don't know. I just don't know the latest number of overall Chrome engineers. I'm sorry, but